Welcome back, Deep Divers. Today, we're getting our hands dirty with SQLite, figuring out how to wrangle images and other binary data.
Sounds fun.
We'll be looking at some real-world PHP code, and trust me, we're not going to shy away from the security stuff because that's, well, kind of important when you're messing with databases.
Right, you can't forget about security.
Now, we know you guys aren't here for the Database 101 lecture, so we're going to be diving into the nitty-gritty of BLOB data, why you'd pick this method over just like storing files separately and linking them up in your database.
Good point. Always good to know the why behind the how.
Exactly. And to help us navigate these murky waters, we've got our database guru with us today. So what's the deal with BLOBs in today's world of ones and zeros?
Well, what I find really interesting about BLOBs is that they give you this clean way to organize all sorts of data within your database. It's super helpful for keeping things tidy, especially when you're dealing with stuff like, say, user profiles, where you want the image and the profile info stuck together like glue.
Yeah, having everything in one place just makes life easier, right? But for those who are just joining us, let's break it down a bit. What exactly are we talking about when we say BLOB, and what kind of data are we stuffing in there?
So BLO stands for Binary Large Object. Pretty self-explanatory when you think about it. It's basically a container in your database for any kind of binary data.
Okay, so not just your usual text and numbers.
Exactly. Think of anything you'd save as a file in your computer, like images, audio, videos, you name it. You can chuck all that into a BLOB.
Nice. So we're embedding entire files right into the database. Now, the code snippet we've got here shows us how to create a table called student profile in SQL. What's the key thing to notice here?
Keep your eye on that profile photo column. That BLOB data type next to it, that's the magic. It tells Salad, hey, this is where we're storing those binary goodies, like our student profile pics.
It's like designating a special shelf in your database for those images. Speaking of which, how do we get those images in there? And more importantly, how do we do it securely? The PHP code we've got here mentions something called FOPN and prepared statements.
You're spot on about security. Prepared statements are your best friend when you're building database queries, especially when you're dealing with data coming in from users. Think of them as your first line of defense against those nasty SQL injection attacks.
So we're talking about sanitizing anything coming from the outside world before it even gets close to our precious data.
Exactly. They act like a filter, making sure that user input is treated as data, not as executable code, which is what those hackers want to sneak in.
That's reassuring. Now, what about this FOPN thing? Where does that come in?
Good catch. FOPN is our way of reading that image file as binary data, which, if you remember, is exactly what we need for our BLOB.
So it's like we're opening up the image file, looking at its raw data, and then putting that raw data into that special BLOB column we talked about.
You got it. We're making that image palatable for our database.
This whole process is fascinating. But let's talk about actually showing these stored images on a web page. Looks like we're back to PHP for this bit. What's the trick here?
Right. So web browsers, they speak a slightly different language than databases, right? They like their images in a format called base64.
So we need to translate again.
You got it. That's where base64 encode comes in. Our PHP code grabs the BLOB data from the database and then uses this function to dress it up all nice for the web browser.
So essentially the reverse of what we did to store it.
Precisely. We take that raw data, encode it into this base64 thing, and then stick it right into an HTML tag. The browser sees that and goes, a picture.
Elegant. We've covered a lot. Creating a BLOB-ready table, securely storing images, even displaying them on a web page. But what if we want to show more than just a lonely picture? What about pulling information from multiple tables, like a student's profile picture along with their grades? Our code's got this cool trick up its sleeve. SQL joins. It uses them to combine data from the student table and the student profile table. So what's the big deal about joins?
Well, think of joins like bridges connecting islands of information. You've got your student data like names, classes, and those all-important grades in one table, and their profile pictures hanging out in another. Joins let you link them up based on something they have in common, like a student ID.
So instead of separate little data silos, we're building a bigger, better picture, right?
Exactly. Plus, your queries become more efficient, and you end up with a data set that actually makes sense. Instead of just a random profile pic, you see the student's name, class, maybe even their grades, all pulled together from different tables with one neat query.
Pretty slick. The example we've got here fetches the student ID, name, class, marks, gender, and of course the profile picture, all thanks to that SQL join magic.
It really shows you the power of a well-structured database.
Totally. Okay, let's say we want to get up close and personal with one specific student's details. How do we tell our database to zero in on that one individual?
It's like finding a book in a library, right? You need that unique identifier.
The Dewey Decimal System of the database world.
Huh, kinda. We usually use something like the student ID to pinpoint the exact record we're after.
So it's all about using the right search terms to navigate this massive sea of data.
Exactly. Our code uses something called a query string to grab a specific student ID. It's basically saying, hey, database, show me everything you know about the student with this ID.
And I'm guessing those trusty prepared statements are back again to make sure everything stays safe and sound.
You bet. Can never be too careful with security,
I
especially when you're plucking specific bits of data like that.
The code uses DIUET to grab the ID from the URL. That's how websites show you different stuff depending on what you click, right?
Bingo. Dynamic web development at its finest. The content changes based on what the user does, all thanks to those clever little IDs.
This is all super cool, but storing images directly in the database, not just linking to them, it seems kind of intense. Are there times when you wouldn't want to do this?
Good question. It's all about weighing the pros and cons. BLOBs are awesome for keeping things organized and making sure the image and its data are always together, which is super important for some applications.
Makes sense, like you don't want a student's profile picture accidentally ending up attached to the wrong academic record.
Exactly. But, and this is a big slow but, storing large files directly in the database can sometimes slow things down, especially if you've got tons of users accessing them all at once.
So it's a balancing act between convenience and performance.
You got it. There's no one right answer. It all depends on the project, the types of files you're working with, and how many people are going to be using the application.
So we've got to think about the big picture, not just the cool factor of embedding images in our database. This deep dive has been eye-opening. You've demystified BLOB data in SQLite like a pro. We've gone from understanding what they are to actually storing, retrieving, and even displaying them with PHP, all while keeping security in mind. It's amazing how much we've covered, and I feel like we're just scratching the surface of what SQLite and BLOBs can do.
Oh, absolutely. What we've explored today with images, it's just the tip of the iceberg. Think about storing other file types, like documents, audio files, even videos, right inside your database.
Now that opens up a whole world of possibilities. Like imagine an online learning platform where students could upload their multimedia projects directly to a SQLite database.
Exactly. Or picture a company intranet, storing all their training videos and presentations in a SQLite database. Easy to access, easy to manage.
Having everything in one place sounds super convenient. But I'm curious, are there any limitations? Like, could we store a 2-hour-long training video in a SQLite database?
That's a great question. Now, SQLite, it doesn't have a hard limit on BLOB sizes, but gotta be realistic. Stuffing huge files in there, especially if you've got a lot of users accessing them at the same time, it can make things a bit sluggish.
So performance is definitely something to consider. It's all about finding that sweet spot.
Exactly. Things like database design, how people are actually using the application, even the hardware it's running on, those all factor in.
So it's not just about whether we can store a huge video, it's about whether it makes sense to store it.
Exactly. And don't forget about those database optimization tricks. They can work wonders, whether you're storing tiny thumbnail images or full-blown documentaries.
Right. Optimization is key. This has been a fantastic deep dive. We've learned that BLOBs are powerful, versatile, but they're not a magic bullet for every single file storage situation.
Couldn't have said it better myself. You've got to weigh the pros and cons, think about data integrity, performance, and what works best for your application.
No one-size-fits-all solution in the tech world, right?
Never. Each project is unique, just like those student profile pictures we were talking about.
Well, I think our listeners are now ready to fire up their code editors and start experimenting with SQLite and BLOBs, all while keeping those security best practices in mind, of course.
Absolutely. And hey, if you run into any roadblocks or have any burning BLOB questions, don't be shy. Hit us up in the comments. We'd love to hear about what you're building.
And that's a wrap on another deep dive. Big thanks to our expert for sharing their SQLite wisdom.
Anytime. Happy to geek out about databases.
Until next time, keep those databases tidy, your code clean, and your curiosity burning bright.